Hey there, Joe Braun of the DCS Mech Warriors. You may have noticed that I don't have any sidekicks today again. To be honest, I think I scared my junior high kids off from making videos. They didn't want to be on camera, so looks like I might be flying solo for this series. We'll see if they visit later on in some of the future videos. But for now, we're going to head into making a op mode that will control a servo using buttons on your controller. And so let me go ahead and switch over to our desktop here. And right now I have everything collapsed. So I'm going to open up team code and go to Java. And then we have our team code folder here. And under that, I have my new member training that we're using as our lesson. So let me open that up. And we're going to actually do this lesson here that I have marked servo with buttons. So I'm going to open this up. And this is our goal, is to kind of get this discussed. If you're just simply doing a servo to run buttons, you don't need all of this. There's some extra tidbits and little tips and tricks in here that we'll talk about as we move through the op mode. But the first thing you're going to need to do, I'm going to actually close this down right now, is go to your YouTube folder if you created one, or just go to your team code folder and you're going to create a new Java class. So I'm going to actually do it inside the YouTube one here. So I'm going to go to new and then Java class, and I'm going to call this one, let's just call this servo 1, which is what we're calling the variable inside this particular program. So I'm just going to push enter. And it creates the package name inside the YouTube folder, and it's called Servo1 here as a class name. I did use upper camel case because it is a class name. So this is what you would start with as a basic op mode. Now in class, what we normally do with my junior high kids is that they have a monitor in front of them that shows them basically my notes, like I just showed a second ago. And then on their laptop that's sitting right next to that monitor, they are actually writing their op mode. So for the video, what I'm going to do is go ahead and open mine so that you can see my notes. And we're going to actually change this to a split screen. So you can drag this around and do right and left split screens, or you can bring it down here and do a top and bottom split screen so that you can see both things going on here. The next thing that we would need to do is go to the op mode that we created yesterday so that we can import a lot of this structure and don't have to retype it. So how we would normally do that in class is we're going to open up this basic teleop structure in the video that we made yesterday. And I'm going to basically copy all of this all the way up. Actually, I don't want the package name, so I'm going to skip that, and also the imports. I'm going to skip those. So I'm going to go right to there and click copy. You can push Control C on your keyboard, and then in the new one that we're going to create, which is here, I'm basically going to put a couple enters here and paste that in. Now, we said yesterday that you don't want to change the name of things without refactoring, but when you paste this in, you've got the old name and you've got the new name that was there originally. And that causes a little bit of a conflict. You don't need to refactor in this particular instance, but you do need to change things to get things in their appropriate spot. You're more than welcome to type all of this out if you would rather do it that way. But we usually just drop it in here, copy and paste like this, and then we go through and change some things. So what I'm going to want to do is I'm going to take this servo 1, I'm going to come down here and double click and paste that in to that particular spot. And then everything else stays the same except for this particular class name is wrong because it's down further now. So if I just delete that out of there, everything's in the correct spot now. And I've got no red errors. I've got nothing red over here on the right hand side. You see some warnings, and that's pretty common in FTC to get lots of warnings, but there's no red marks. So everything is named correctly. I said in yesterday's video that we'd teach you how to refactor. So say I didn't like this name and we wanted it to be something else. So instead of just typing the name here, it won't change it over here in the left-hand structure, and it won't change it in the package name. To do that correctly, what you should do is right-click and go down to the word refactor and rename. You can also do this over here in the left-hand menu. So you would want to find this particular op mode or Java class. So you would come down here to Servo 1 and then right click and refactor, and you can do it in either spot. So I'm going to rename this Servo 1. Can't even think of anything unique here. So we'll just call it Servo 1 test. And put, it erased everything. So let me put that back. Servo 1 test and push enter. And that refactors it here and it refactors it over here. And everything is happy now inside of the Java workspace here. So that's how you would refactor or rename something if you didn't like its name that you were using. Okay. So this one on the top here, I can go ahead and get rid of our example now because we've copied and pasted that in. We've got our basic structure now in this new class that we've created, and we're going to use our notes now to go ahead and work through and talk about some things. So let me go ahead and collapse that menu on the side. Again, to do that, all you have to do is push this button and then project. If you click on project, it'll pop it back open if you need to see that. So that's how I did that. And then looks like we're fine as far as our split screen. So let's start at the top and start working our way down. So in this particular instance, we have our package name, which those would be different. That's perfectly fine. Inside our imports, we don't have a whole lot of imports, but there's 3 in the top and only 4 in the bottom. So at some point we're going to be adding some more, it looks like, but that should happen on the fly. Our configuration file, we are going to use a servo port. So what we usually do is in our config file, we go ahead and notate that. So the first thing we're going to put here is we're going to be using the control hub. So we'll make note that this is on the control hub and not the expansion hub. And then we're going to do a servo port 00. The first one is 0. And then we put the variable name that we're going to use. So we're just going to call this servo 1. If you're making an FTC robot, you would use something more descriptive when you're actually building your competition robot. So like this is the claw, the servo on the claw. So you might just simply call it claw. But for now, we're just going with generic names. So servo 1 will do. So now we need to create that variable. So global variables, if you remember, go right here below the class name. And so we're going to jump down to right below the class name, and we're going to put a couple enters in there, and we're going to create that servo. So private, we're going to call the class servo. That's in the SDK by First Tech Challenge. So that was in the repository, so you don't have to create that class. It's already part of the system. And then our variable name is going to be servo 1, and then end our sentence with a semicolon. So now we have a variable using this particular configuration file name. And then in Java, we have that same variable. So just so you understand, the configuration file is how the hardware is basically mapped to what you're programming in Java. So sometimes you'll hear it referred to as a hardware map. But what we need to do is when we plug in a wire on the control hub, we need to be able to tell the system, so Java is wanting to use servo 1, that variable, where is that servo or motor or sensor actually plugged in? So it's making a logical connection between what you're writing in code and where it's plugged in as far as the hardware on the control hub. So this is the name that we're going to use in the configuration file on our robot, and this is the name we're going to use in Java. So those do need to match up, or you will obviously get some errors. Okay, so the next thing we're going to do is, right now this is labeled as disabled. If you were getting ready to upload this code to your robot, you would obviously need to comment that out, but right now we'll leave it disabled. We are going to do this in teleop and use a controller because we're wanting to attach it to buttons. I think we said you can put primary, secondary. Here you can basically put any title you want for group. You can put a name, if you refer back to the previous video, that can be a different name than what your class name is, but with nothing in here as far as name, it will use whatever the class name name is, and that's the way we like it. So this one, we're just going to put this under example as far as a group, because this is in a competition robot. So we're going to create a group called example. And then our class name is already set up, so that matches down here other than the name itself. So we're down to the rest of our variables. I guess we can go ahead and discuss those. We're basically just creating buckets. And what I'm going to do is just simply, because I'm not the best typer, one of my graduated seniors, well, he graduated a year ago, said that he learned how to code just by correcting all of my typing mistakes. So I'm just going to use copy and paste and cheat a little bit there. So what we're doing is creating another variable, so private. Primitive type is the word that I was trying to remember, is a double. So we're going to be storing decimals inside this bucket. The name that we're using is done in lower camel case because this is a variable. So servo1 init position. So when we init the position of servo1, this is where it's going to go. We're also going to have init, servo1 position 1. So we're going to move it to something other than its initial position, and then we're going to have another spot, so servo position 2. So in a competition robot, this might be for us init position and then open claw or close claw, something like that. Again, we're just doing generic names, so we're just calling position 1 and position 2. And then this particular piece we're going to come back to. It's something that we don't necessarily recommend using in teleop, but we wanted to go ahead and discuss it just as kind of like an extra little perk. So we'll come back to that specific one, but again, it's a variable using an integer, and we're creating a delay. So again, we don't use sleep in teleop because you basically lose control of your robot when you put your robot to sleep. But just to show you something you could do maybe in autonomous if you crossed over to that with a sleep. So we'll come back to that particular thing in a few minutes. So we're going to go ahead and move down to our structure that we talked about yesterday. Again, just to review that real quick, when we push a init on the robot, we want things that are going to happen one time. So all of our hardware that we're going to initialize, so in this case, just one servo, we want that to happen. And then things that are happening over and over again before we push play will go inside our while loop. And then whatever is here, wait for start, actually is looking for us to push the play button. The part that I was thinking about for a second, you can have an extra inner in here for things that you want to happen one time. So say you want to turn off your camera, that would go in here. And then after play is pressed, that's going to happen one time, and then it'll head into the while loop. So this is where you usually put your drivetrain for a teleop. Again, we're just working on servo, so we'll have some servo controls in here instead of a drivetrain controls. But that's kind of the structure of how that works. So let me get rid of that enter. And so we're going to work down through here. So init hardware, we only have one hardware piece. So that, again, as far as method stacking, there's only one method inside of this init hardware. But again, if I had 3 servos, all 3 servos would go inside this particular method. Java has changed this from the way that we would normally type it to kind of a shorthand way. If you click on the bracket, it will put it back in the expanded form. And this is the way you would normally see it. But since there's only one item inside this particular method, it did go ahead and put it in the shorthand way. Again, you can expand it just by clicking on the bracket. So we would stack, if we had another servo, we would put another method here. And if we had another servo, we'd put it here. So we would just stack all those methods in there. Since this is the first one we're actually making OpMode, obviously there's only one piece of hardware at this point. Okay, so the next thing we want to do is create this method that's being called by the init hardware. So right now, there's nothing inside this particular method, but we're going to create the method that we want to call down below it. So I'm going to cheat just a little bit. I could copy from down here, but I'm going to just copy this particular method and paste it in. Obviously, you get a red error. That's kind of the reason I did that. We have a method named by the same name, so we do have to change this so that it knows what to do. And we're just going to call this init servo 1 in lower camel case. And then the 3 steps that we need to talk about when we set up a servo is first the hardware map, which you see on line 43 here. So servo 1, which is the variable name that we created up above, we're going to instantiate that or set that equal to, and then we need to map that to where the config file is going to find its information on the robot controller. So that's the hardware map.get. It's looking for a servo, and then that servo name is servo 1. Okay, so that piece, you're going to type all of that in. I'm going to copy and paste and drop that in right here. So now Java knows when it sends its code to the configuration file, actually sends it to the robot controller. It's going to look at that configuration file and know where to send the signal to as far as what down what port, as far as running that particular servo. Okay, so it's found the servo, it knows where to send the signal. Is probably a better way to explain that. So the next thing that we want to talk about is, do we want that servo to, when we send it a positive signal, do we want it to rotate in the forward direction, or do we want to reverse that? We can logically switch a servo to go in a direction. Now this is an optional step, but we always put it so that all we have to do is when we come in here and we want to reverse it, we're just going to change that to reverse. And I did a lowercase e, but it did find it. So if I push tab, it'll put it in all caps, which is what's required for Java to know what to do there. So if I wanted to reverse it, that's all I'd have to do. If I wanted to do forward, I can type forward and then tab, and it will find it there for me. So the next piece that we always set in our init is, where do we want it to go when we push the init on the driver hub. So we always, for basically safety reasons, we always tell it where to go automatically, like where do we want to start. And you're probably gonna have to do this on a competition robot, because if your servo is kind of like falling out of the start position, the 18 by 18 by 18 start location, it needs to pull itself within that. So we always set an init location of that particular servo in our hardware setup, so our init method in this case. So up top, we created a variable called servo1 init position. So where do we want it to start? And we're starting it halfway in this particular example, halfway through its motion. So servos go from 0 to 1. So one of our positions is 0, the other position is 1, so it'll turn about 180 degrees in a standard rotation servo. You can get a continuous rotation servo, that'll be a future lesson, but a servo that's in standard rotation usually rotates about 180 degrees, and our init position is halfway through, so 50% or 0.5. Okay, so init is where we're going to start that. So now we've created this method to init the servo with all the information, the setup information that's required, but we haven't called it. Okay, we haven't used it, so it's grayed out. So what we need to do is, when we init our hardware, we need to call this particular method. So init servo, and again it found it, so I'm just going to push tab, and so now it's going to init servo 1. Now this seems like a little bit of overkill if you're just programming one servo, okay? But if you're programming 12 servos, this is it makes things make more sense logically, that you will have the big picture up here that we're initting a hardware, and then all of our hardware that we're initting will be listed out here with its own individual method, because we're going to have servo 2, servo 3, and so on. Okay, and then each one of those methods will have its own init method down here that then you can look at with all the settings all in one spot. They're not spread all over the place. You would have something like this up here. If you didn't use this particular strategy that we're showing here, you would have this several times for each one of those servos. and it gets a little bit confusing about what's actually happening big picture. So I'm going to Control Z and get rid of all that. So what we're trying to do is make our code look a little cleaner by using method stacking. Okay, so each one of these pieces of hardware will have its own method, and all of the settings for that particular method is inside the init method that we're creating. Okay, so again, this will make more sense as we add on more pieces. Again, I understand it might feel like a little bit overkill with just one piece, but we try to teach kind of habits in the class. That this is in general when you get into bigger coding schemes like 2000. Our competition robot is usually about 2,000 lines of code. It's a lot harder to find stuff and see the big picture unless you do it this way. So this is the way that we have our junior high students learn it. And so when they come up into FTC, they're able to just start running with the program the way that we already have it set up with our thousands of lines of code. So hopefully that helps. The next thing that I want to talk about is we need to actually create a method that's going to use the data that we're getting from that servo. Okay, so when we're in the while loop, just sitting waiting for play, let's actually put some telemetry on the screen. So what I'm going to do here, I'm going to come back to this. This is the extra little piece that uses a thread sleep that we don't want to necessarily use right now. So I'm going to come down a little further right here to our servo telemetry. So again, this is a method. You know that it's a method. Actually, there shouldn't be a space there. That wouldn't cause the code to be wrong, but normally you don't have a space before the parentheses. So what this is basically taking all the data that's coming back from the servo and putting it on the screen. Now, we don't use hardly any of this. Like I said, we'll just give you some extra pieces, some extra little tidbits that you could use in this particular lesson because it is simple. So you can get some data and display it on the screen about what the position is or where the servo thinks its position is. So if it thinks it's at 0.63 or whether it thinks it's at 100%, which would be 1. Or does it think it's at 0.23? So you can display that data on the actual screen and be able to make some troubleshooting adjustments. Okay, so direction, whether it's going forward or reverse, the controller, the port number, again, all of this information is just kind of extra. The ones that we usually use is just simply position, but you can pull the manufacturer. And how do you find that data? Well, if you push Servo 1, let me go, we'll go right here. If I type in Servo 1 tab dot, and then I type get, all of these things are listed out. This is information that I can get from that particular servo. And so basically we just took all of these methods that you see here. These are method calls to get the information. And we created telemetry data that we can put on the screen. So we can find out all of this information about the servo and display it or use it some other way. Again, you don't necessarily need to create all of this. You just maybe want to mess around with some of it. So let me get rid of this particular spot right there. And let's go ahead and create a method down here for this telemetry. So a method starts with public. We don't want it to talk back, so it's void. We'll call this servo telemetry. Did I spell that right? I hope so. And then we're making a method, so parentheses, space bracket, enter. And now we have our method created. So I'm just going to use the data off of the top line here. So we're going to clear off our screen. We're going to find the information that we want. And then we've got to actually send it to the screen. And to send it to the screen is this telemetry.update. So now the only thing that we're doing on this particular one that we're writing actually live here is displaying the servo position. So what position, what PWM signal is it being sent? as far as a decimal. Now, again, it's grayed out because I haven't used it. So now that we've created a method, we need to use it. So where are some places that we might want to use it? Well, we would want to use it maybe while we're waiting for the play button to start. So we could put that in right here in this particular spot. So it was Servo 1 telemetry, or Servo telemetry. We didn't call it Servo 1, we just called it Servo telemetry. Now, we might want to do that again down here in this while loop. So we press play, and maybe we want to update our location on where that servo is as we use the controller to move it around. So now it will still update during the op mode. So while the op mode is active, it's still sending that telemetry down. Okay. All right. So now the next thing that we want to do is actually be able to control or move the servo. So what we're going to do is find our teleop controls. So we usually create all of our controls inside a method. We don't hard code those up here in this particular spot. Again, we want this to be kind of the bigger picture. So we're going to create a method that actually calls those controls so that our big picture stays nice and clear up here in the main run op mode method. Okay, so a lot of teams will probably put the controls right here, and then you got to sort through lines and lines of code to figure out what the big picture is. But we're going to create a method, so we're going to do that actually here after the init. Wrong line, right there. So I did notice in one of the previous videos I highlighted a code block incorrectly. So let me kind of discuss that real quick. This code block is creating a method all the way down to here. So we've got an opening bracket and a closing bracket all the way down here, but there is a nested code block right here, or a child code block inside that. And then here is another one right here. So this one is inside of the bigger one, the parent. This one is also nested, or a child, inside of the parent. And the parent one goes all the way down here. Now, overall, the bigger picture, there's a code block here that goes all the way down to here. So this is the class code block. And then inside of this class, we have our main function that we're overriding. And that method goes down to there. This method is there. There's another one. And then we're getting ready to create one in this space. And then we've got one here. Okay. So an opening bracket has to be closed. If I get rid of this closed bracket, it'll throw an error over here. You see that there's one error because it's looking for a closure of this one. And right now it's taking this as the closure. So therefore this one up here doesn't have a close. So it's lost. It doesn't know where, it just can't find where everything's supposed to be. Okay, so we're going to put in a bracket here. And so now this method, see the line coming down here, this closes this particular bracket. And this one, the line is actually, this line here goes all the way up to where the class began, right here. And since it's, well, it's kind of the yellow line that was off to the side. There it is. You can see the yellow line because the line would be on top of the gray line. So looks like the IDE for the class puts it out to the side with the yellow line. All right, so now let me go back to creating our new method. So we're going to create a new method in here. So for that, it's going to be public void, because we don't want it to talk back. We're going to call this teleop controls. And then this is a method, so parentheses, space, and then our bracket, and then enter. Okay, so now this is where we actually get to use the servo. We're actually going to give it some functionality off the controller. And so that first one is we're going to program if the A button is pressed on gamepad 1. So if this is true, again, that's a shorthand way of writing this. It means the same thing. So if this statement is true, then execute this code. If it's not true, in other words, it's not pressed, it's not going to do anything. Okay. If button B is pressed, it's going to do this. If the right bumper is pressed, it's going to do this. Okay. So what we want to do, let me actually correct my notes here. Take that back. So we're going to write that in right here. So again, if we have a conditional statement, and then if that conditional statement is met, we're going to, and then a nested child code block. Okay, so what is the code that we want to do if this conditional statement is met? So again, what is the conditional statement? Well, we're going to push gamepad 1 A. You can type that out or just tab. And then what is the code we want to do? Well, we want servo 1 tab to set its position, set position 2, and then we're going to call a variable. So servo 1 position 1. Now, could I change that to hard coding the number in? So say I wanted to move to 20%. I can hard code that number in here, but that would be poor execution of our coding knowledge. Okay, so think again about young junior high students stepping into our fairly advanced team. We do pretty good with our coding. And they need to sort through 2,000 lines of code to find where that servo position is set to. That's a little bit of finding a needle in a haystack, especially if you're brand new and don't know kind of the setup of how things work. So it's usually bad form to hard code numbers into things below the global variables. The global variables is where you want to hard code your numbers, and then call the variable down here further in your code that then we'll use that number up here at the top. So in Algebra 1, again, I was a math teacher for a long time. In Algebra 1, we simply call this substitution. So we're going to take this variable, and where that variable is, we're going to substitute in a number. So in this particular case, we're calling servo 1 position 1, which is set to 0. So I could have hard-coded a 0 in here. Just as a side note, we usually put 0.0 to signify, hey, this is a double. And when it's an integer, we usually obviously don't put the number because it won't allow it. So if we were to put hard code 0 in here, we'd put 0.0. But again, that's bad form. We want to do servo position 1, servo 1 position 1 if A is pressed. Okay, so now all I'm going to do is copy. So Control C on my keyboard. I'm going to push enter. I'm going to paste. And now what if I push B? Well, if I push B, I want that to go to position 2, according to my notes here. So I'm going to change this one. What I can do is go to the end and backspace, and then type a T, and then tab, and it'll fill in that particular variable automatically for me. Okay, so now if I press A, it's going to go to position 1. If I press B, it's going to go to position 2. Okay, well, that's the thought, but again, this is grayed out. So I've got a method here that I've created the functionality, but I've not used the functionality. So now that I have this method, I've got to actually use it. So I'm just going to copy that since I double clicked it. I'm going to come up here, and where do I want to use that? Well, we want to use teleop controls when it's in, once play has been pressed and it's in this while loop. So I'm going to press that, or I'm going to paste that right here. Now it's a method, so it should have parentheses and end with a semicolon. I'm going to get rid of that extra space. So now once play is pressed and the op mode is still active, it's going to run my teleop controls, then it's going to run the telemetry. It's going to run my teleop controls, then it's going to run my telemetry. So it's going to move the position, and then it's going to say what that position is on the screen. It's going to do that over and over again until the battery dies or we push stop, right? Okay, so there's one other function that we wanted to create down here, and that's definitely more complex. We do not advise doing this in teleop, but if this was an autonomous, maybe you want to slow down your servo. So servos, you set to a position, and it moves there as fast as possible. So if I move it from the 1 position, 0, all the way to 100%, which is about 180 degrees, it's going to do it as fast as it can. But say I need that to slow down. Okay, so one of the things we use in maybe an autonomous, again, this is set up as a teleop, so we wouldn't do this ever in a teleop because, again, you'll lose control of your robot while the thread is sleeping, so it's not taking any commands. Well, if your command for your robot was to drive forward and then it goes to sleep, it's going to keep running into the wall or whatever while it's sleeping, and then when it wakes back up, you'll get control again. But again, thread sleep, we don't normally recommend in teleop. So maybe in autonomous, you would use this little functionality to slow down a servo. And that slowdown is happening via a for loop. So I'm looking for the, oh, here's the code right here. So in this series, we've not covered a for loop, but in our Arduino class that my junior high students are coming up through, they've used a lot of for loops. So this is a pretty easy thing for them to pick up. But what we're going to do is run something over and over again for a certain number of repetitions. And once it gets to the max of those repetitions, it's going to exit out and do something else. So let me kind of step through this particular one. Actually, I'm just going to copy this right here. I'm going to come down to right above our telemetry. And I'm going to paste that in. And I'm going to actually talk about it up here. So let me get a little more space. All right, we had several bells go off there, so I had to pause the video, and now I'm coming back to kind of explain this slower servo. So the range right here is doing a math calculation before we head into the for loop. So basically, we're using a double. We don't need to use the keyword private because it is a local variable. So we're using a double primitive type. We're setting our variable name to range, and we're instantiating that or setting it equal to this math calculation. So we passed it the end position. We have passed it the start position. So we're subtracting those. So say this is, I don't know, 50, and this is 25. So 50 minus 25 is 25. And actually, it would be 0.25. So 0.50 is the set position. 0.25 would be the start position. So 0.25 would be the math calculation for this parenthesis. And then we want to get that into the number of reps that we want to move this. So we multiply that 0.25 times 100 to get 25 times, okay? So it's just doing a simple math calculation of where it starts, where it ends minus where it starts, multiply it by 100. Okay, so now we're down to the for loop. So the for loop is going to execute the code for a set number of times. So in this case, we just calculated that out to be 25 times. So there are three pieces that you need to input into a for loop. The first one is a local variable. So we have an integer. The name of that integer variable is going to be I. It's pretty common for a for loop just to use the letter I for the variable name. And then we're instantiating that to start at 0, which is also pretty common. Okay, the next piece is going to be the conditional. So we need this to be true. So if I, in other words, 0, is less than or equal to the range, which we did a math calculation up here for that. So that's 25. So if 0 is less than or equal to 25, this is conditional. So it's going to execute this code. When it's done, it's going to take I and add 1 to it. This is a shorthand way of incrementing I. This means I plus 1 and then sets it equal to I. So if this goes through the code one time, 0 is going to change to 1. If it goes through the next time, 1 is going to change to 2. And it keeps incrementing I and calculating it, tracking it each time it goes through until it gets to 25. Well, actually 26 because we said equal to. So on the 25th time, it'll still run it. 26, it will not run it. This conditional statement is now false. It will exit out of the loop and continue with whatever we put after this bracket, okay? So now let's talk about what's inside the bracket. So we are going from our start position, servo1.set start position. We've talked about how to set a position for a servo. So it's going to take that position and run it to that location, which so the first time through, it's not going to do anything. Okay. It's going to sleep. In other words, put the thread to sleep. In other words, not taking any more commands for 10 milliseconds because that's what we have this global variable set to. Okay, and then it's going to take the start position that we passed to it, and it's going to add 0.1 to it. So if it was at 0, I think we said 0.25. I can't quite remember the numbers, but if it was 0.25, now it's going to be 0.26. If it was 0, now it's going to be 0.01. So whatever the start position is, it's going to add 0.1 to it. And then it's going to run through the loop again because now it's going to increment, and this is going to be a 1. So each time through, it's adding 0.1 to it until it gets to the position that we want it. So now to slow it down even more, we can change this delay time and get our servo to move even slower by changing this number. But it's going to run through the range, which I believe was 25. So it's going to run through this 25 times until it gets to the position at once, and then it'll exit out because the conditional statement will then be false, and it's not going to move the servo anymore. But that's how you might slow down a servo. Just the thought on something that, depending on next year's game, you may or may not be able to use that, but you can get a servo to move a little bit. You can't get it to move faster, but you can get it to move slower if you need. Again, we only recommend that in autonomous, not teleop. So what I would want to do now is kind of check out, make sure I've covered everything, make sure I didn't miss anything as far as our explanation. Just kind of glancing real quick. Actually, as I'm looking at this, we did not use that particular method ever. So let me just double check everything else and make sure. Okay, here it is. That's where we're using the method. So if we push the right bumper, we were using this slower method. So for instance, you need to make it move from one position to another position in a slower speed rather than immediate. So immediate was A and B, but we want to slow it down. We set this up for right bumper. So let's do that real quick so we can walk through the code and actually using it. So servo 1 slower is what we're calling. So we're going to put an if. And then our gamepad, what did we call it? Right bumper, maybe? It's covered up. Okay, gamepad 1, right bumper. And let me just go ahead and tab. So if this statement is true, in other words, that has been pressed, we want to run some code here. So what's the code? Well, servo 1 slower is the method we want to run. So now it's asking for these arguments to be put in. So the first one is the start position. Okay, so we're going to call that servo 1 position 1. So that one right there, comma, and now it's asking for the end position. So we're going to call that servo 1 position 2. Okay, and then comma, and then now it's asking for the delay. Well, we simply call that variable servo 1 delay. So I can tab. And so now this looks like it's complex, but it's just, again, substitution. It's replacing the numbers. So the servo 1 position is this one right here. So it's moving from 0 to 1, position 0 to a 1, 100%. And it's using the 10 millisecond delay to do that. So now if we upload this code to our driver station and we push the right bumper after we have initted this and push play, it should move that servo much slower than it would at 100% speed by pushing A or B. Okay. All right, so that looks like we've covered everything in my notes. So in the next video, we are going to attach a servo to a joystick so that you can use the sticks to move that servo back and forth. And when you let go of it, the stick moves back to 0 and the servo would move back to the 0 position. We'll show you how to do that in the next video. But for now, I think we're going to wrap this up. So any comments, any questions you have, put those obviously down in the comments. And we hope to see you in the next video. Catch you later. Bye-bye.